Hello everyone. We are making this video for our course Software Testing and Quality Analysis under the guidance of Professor Saurabh Tiwari. We are a team of 4 members from DICT: Shubhadeep Maji, Gaurav Bansal, Nikhil Tekwani and Aviral Mithal. JUnit. JUnit is a unit testing framework for the Java programming language. It is important in the test-driven development. JUnit promotes the idea of first testing and then coding, which emphasizes on setting up the test data for a piece of code which can be tested first and then can be implemented. JUnit provides annotations to identify the test methods, assertions for testing expected results, test runners for running tests. JUnit shows test progress in a bar that is green if test is going fine, and it turns red when a test fails, as we will be showing later. To know about JUnit testing, you must first know what a unit test is. A unit test case is a part of code which ensures that another part of code, such as a method or function, works as expected. To achieve those desired results quickly, test framework is required. JUnit is perfect unit test framework for Java programming language. In our video, we will be talking about annotations in JUnit, creating test cases in JUnit, infinitest for regression testing, testing of private methods, and testing of concurrent methods.
To show the functionalities of JUnit, we will be using a code which contains basic mathematical functions used frequently like power function, GCD, square root, etc. Now I will be talking about annotations in JUnit. Annotations are metadata in JUnit which contains data about the code following it. Annotations are written using @ followed by its name. Let's get started with @test annotation. @test annotation. The test annotation tells JUnit that the public void method to which it is attached can be run as a test case. To run the method, JUnit first construct a fresh instance of the class, then invokes the annotated method. Any exceptions thrown by the test will be reported by JUnit as a failure. If no exceptions are thrown, the test case is assumed to have succeeded. The add before annotation. When writing test, it is common to find that several tests need similar objects created before they can run. Annotating a public void method bit with add before causes that method to be run before the test method. The add before methods of superclasses will be run before those of the current class. The add after annotation. If you allocate external resources in a before method, you need to release them after the test runs. Annotating a public void method with add after causes that method to be run after the test method. All add after methods are guaranteed to run even if a before or test method throws an exception. The annotation add before class. The add before class and add before are same in functionality. The only difference is the method annotated with add before class will be called once per test class based, and the method annotated with add before will be called once per test based. The annotations add after class and add after are same in functionalities. We won't be using either of before class or after class. To create a JUnit test class for a particular class, right click on that class, click on new, click on JUnit test case, then select the stubs you would like to create, then click on next, select the stubs you would like, the methods for which you would like to create stubs, then click on finish. Here you will be able to see all the stubs and methods that are created. Now I will be showing how to create test classes from scratch. We have already shown how to make a test class. So click on finish. Now first I will be making an object of the class sample class. Sample class has some basic functions like power and multiply. Now I will be creating the test cases. First, I will be initializing two integers a and b to some numbers. Uh, Now here I will be calling the function multiply from sample class. So I will check if it is same to as what we expect. Assert equals basically checks equality of two objects. These two the objects can even be numbers, integers or strings. Now to run the test case we need to go here, and yes, we need to save it. We can see that all the test cases pass. Now when we change its value, so when we change the expected value to 7, we know that 2 multiplied by 3 is 6, so the test case should fail. We can see it here. So now I will be creating a test for the method power. So I will be running the test case again. Here we can see that the test case passes. When we change its value to some unexpected value, we can see the test case fails. Now I will be telling you why not to write two test cases under one add test annotation. Now suppose we have checked here for two assert equals. Suppose that both of them fails. We know that both of these will fail. Now when we run it, the JUnit only shows that one of them fails. It doesn't tell which one of them fails. When we double click it, it just shows the first one which is failing. So it is highly recommended to write each test case under different add test annotation. So I will be doing that. I will be removing the power stuff from here. Okay, I will be running the test case again. As you can see, we have run two test cases. One of them fails as expected. Now here we can see that we have used the same variable twice, like a equal to 2 and b equal to 3. We have used them twice. Suppose we have more than two test cases, like maybe 10 or 20, and we need to use the same variables again and again. I won't be wanting it to write again and again. So what we do is we write these in add before method. So I will be writing it only in add before method, and I will be removing it from both of them. So okay, I first need to give them scope of access. Okay, now I have declared the variables in the class and initialized them in the add before method. So when I run this test case, I can see that both of them fails. I don't know why. One should have passed. Okay, so pardon me for the error. I got hit what it was. So basically what was happening is we declared the integers a and b here, and then the add before annotations again declares it here. So the eclipse should give an error, but it doesn't give. So when we run this, it says it fails. So when we remove this integer redeclaration from here, we can see that the test passes as expected. Uh, Now I will be showing how to use at rule annotation. At rule annotation is used in place of at before and at after. What it basically does is it allocates the memory and initializes the variables for like in at before, and it also works as at after, like it uh, deallocates the memory which has been dynamically allocated. I will show how to do it. I will comment at after as it will not be required now. So this is showing an error because we have not imported the header file. Now I will run it. It is still showing an error called initialization error because we need to extend our class to by test case. Okay, now we are done. Now we can see that at rule is working similar to uh, at before. I'll change the value and you can see the test cases fail as expected. Now after at rules, I will be talking about parameterized testing. Uh, Parameterized tests allow developer to run the same test over and over again using different values. The test case will be invoked once per each row of data. Let's see parameterized tests in action. First of all, I will like to talk about this class. It is a simple class named area, and it has a simple function called square which returns the square of the number. Now I will be making a test case test class. So we have already shown how to make test classes. Now for testing, parameterized testing, we need to write at run with parameterized class before the test class. Uh, we need to import the header file. Eclipse is good, it shows us hints. Uh, okay, we are done. Now I will be declaring some numbers. Okay. Now I am making a object of type area. I am naming it A51 as we like area 51. Sorry, this is a typo. Uh, then in const no. I am going to replace add before with add rules. Again I need to import rule. We will be removing after as we don't need it. Okay. So then we need to write a method which will have our test cases. To identify that method, we need to write an annotation named parameterized dot parameter. Okay, so this after this annotation is going to identify our uh, I'm making my method. I will be returning a array as list. This is how you write the test cases. Now uh, in here you write your test cases, like I will be, our function is squaring, so I will be writing like 1 and 1, 1 and 1, then 2 comma 4, then 4 comma 16. Okay, I think this will be enough. Okay, so we need to import some more stuff. Wait. Sorry, we had a typo. So okay, this will be returning these will be our test cases. Now moving on to the test method. So I will be printing out the numbers which are given as input. So the input number, and the answer. Okay, I have a typo here also. Now we will be checking if the answers are correct or not. I am calling the square function from the area class. Okay, actually we need to use the object. Okay, so we are done here. Okay, no, we are not done. What this method does is this it gives these values to the constructor of the class. So for we need to make the constructor of the class. So I will be making the constructor. So now in every test case these values will be going to the constructor, and the values in input number and answer are going to be initialized. Now I will run the test case. As you can see, all the test cases pass. Now when I change the value of 1 2 3, you can see that the test failed. It also shows which test number fails. Like when I change this value, it also shows that this fails. Okay.
Now we would like to familiarize you with infinitest, which is a plugin for Eclipse and runs every time a change is made in the code. It is used to test JUnit test cases and runs all the test cases that might fail because of the changes in the code. Now we'll tell you how to install infinitest in your Eclipse. To install infinitest on your computer, open the website infinitest.github.io. There's a link given on the website. Just drag and drop the link onto your Eclipse. Download will start automatically after a little confirmation. Click on confirm. Now accept the terms of the license agreement. Click on OK. The download has finished. Now you need to restart Eclipse before continuing with your work. Click on yes. Alternatively, to install infinitest, just copy the link given here and go to Eclipse, help, install new software, paste infinitest and click on the checkbox and click on next. Now next, accept and finish. Plugin will install in a few moments. Allow it to run in the background and restart whenever the download has finished. Now after installing infinitest, you can see a bar at the bottom of your screen. The green bar shows that all the test cases ran successfully, and if the bar turns red, that means a test case has failed. Now see, if this is the test case for the power function. The value given to the power function are 4 and 4. So 4 raised to 4 is equal to 256. But if I change the value to 255, the test case should fail. And see, the test case had failed. Now if I change the value again to 256 and save the file again, the bar will turn green, which means the test case ran successfully. Infinitest can not only detect changes in the previous code but can also detect changes if there is a new test case added to the code. Like in this code, I have removed one of the test case and saved the file, and all the test cases ran successfully. Now if I add the test cases again and save the file, the test cases run successfully again. Now if I make some changes in this code and save the file again, you can see the test case has failed. So we can see that infinitest can not only detect changes in the previous code but also can detect new test cases if they are added to the code.
Till now we have only tested public and protected methods. Now I will be showing you how to test private methods. Private restricts the access to the class itself. Only methods that are part of the same class can access private methods. Here we have a class called sample, which has a private method called add. It simply returns the value plus 10. Okay, so what we will be doing is we will be using reflection. Reflection means that we change the behavior of the code at runtime. So what we will be doing is changing this private method to public during runtime. So here is the code for the test case. What I have done here is, firstly I have declared three things. T is of sample type, X is of class type, and O is of object type. And here in before I have initialized them. Okay. Then in test, I have again initialized the method to null, which is, I don't think it is required. Okay. Then I have here comes the important part. I have equaled method to this value, x dot get declared add integer dot type. What this means is, x is the class type which has been declared to t, and get declare method identifies the method on which we will be testing. So add here means this add, and integer dot type means the input which we will be giving to the function add. So we can see that here we have integer type inputs. If we have more than one input, then we have to add it like this. uh, okay, so I have just added try catch so that there is no error. Mm, then it is the first important thing. Then the second important thing is to make this accessible. We are making this accessible at runtime by setting it accessible to true. Then the third important thing is invoking the method. So here we are, O is the object which we had earlier created here. Now we are invoking the method. So on invoking the method, we have already declared the method add. So on invoking the method of this method, the add is invoked, and it returns the value of 1 plus 10 to O. So O is now 11. Then we check for equality using assert equal. Now I will be running the test case. As you can see, the test case passes as expected. Now I will change the equality test. Now the test case fails as expected.
Now we will use JUnit to find concurrency errors. What is a concurrency error? Concurrency errors occurs in multi-threaded software when different threads access the same variables, creating base conditions. For example, imagine two threads that are taking a variable from the memory and incrementing the number and storing it back. So what we expect is thread 1 will first take 3 from the memory, store it in its own register, increment it to 4, and then store it back into the memory as the number 4. Then thread 2 will take the same number 4, store it in its register, increment it to 5, and then again store it back to the memory. So the actual final answer in the memory will be 5. But what actually might happen is that the thread 1 will take the variable, take the number 3 from the memory and store it in a register reg1. Then thread 2 will take the same number 3 from the memory, which t1 is still not modified, and store it in its register reg2. And then reg1, then thread 1 increments it to 4. Thread 2 also increments it to 4, and then thread 1 stores it back to the memory as 4, and thread 2 stores it back to memory as 4. So instead of 5, we are the final answer is 4, which is not what we want. So concurrence errors thus can be really hard to find. Many times websites go for years without finding the error until someday they find out there's a small concurrency error in the database has lost them millions of dollars. Test cases, we can have test cases, but they'll work for the module numerous times before we actually find the error. So it is imperative to detect these errors by running the modules in many more threads than required. Maybe a order of magnitude of 1 or 2 greater than what is required. So if we think that 100 threads would be running using this module, we should run it on 1000 threads or more. Thus concurrency errors in JUnit can be really hard to find, and I will show you how to do it. Okay, so here we're going to learn how to test for concurrence errors in our program. So this is a basic counter program. So it initializes a variable to 0, and then every time we call the function add1, it increases it by 1. So 1, 2, 3, 4, and there's 1 to get the value of the variable count. So I've already made the test case for counter test. Uh, we don't need to set up, we just initialize the counter variable as C. Then I'll explain this later. Counter test is an array which has a lot of has 10,000 variables. 10,000, it's an array of 10,000 size. We initialize all of them to the constructor of the function of the class. Then we create the threads. So this basically creates a thread. It extends to thread. So dot start means that will create a thread, and then after that we will join it. So when we run start, the function run function is run in by the thread. So it will do c dot add one, and then I've printed c dot get count just for our knowledge what's going on. And when we tear down, we'll assert equal if c dot get count is equal to the number of threads. So now we will see that when we increment together, many threads increment together, there can be problems such as the variable is incremented only once instead of twice or maybe thrice. So I'll just run the test case. And we see it's failed. So and the final answer was 9999, but it's supposed to be 10,000. So we see that it's failed. So now I will log the variable. Okay, so now that's logged. This should give the correct answer as 10,000, and there should be no concurrence error. So I'll run it once again. So we see there's no errors. So what we did basically is that though JUnit has nothing built in to check for concurrence, we have made our own function. In our own test case, we have made threads and checked that if the function is called many times, is there an error. So if I'd used 1000 instead of 10,000, perhaps it wouldn't have given an error, and sometimes even 10,000 might not give an error. So it is up to the person making the test case on how big the number to select based on the usage. So if this thread would be maybe used 100,000 times, so maybe I should have put 100,000 times to make sure I get the correct answer.
Now, with this, we come to the end of the tutorial. We learnt about JUnit and its annotations, making test cases for JUnit, advanced annotations like add parameters and add rules. We also learned about infinitest, a plugin for Eclipse which runs test cases as soon as a change is directed in a file. We also showed how to test private functions, and finally, we saw how to test units for concurrency errors. We hope you found this video helpful in understanding some lesser known functionalities of JUnit. For any queries or suggestions, please comment on the video or contact us on the email IDs on the screen. Feel free to contact us anytime you want. Do like, share and subscribe to this channel. Thank you and happy testing.